Okay, so this is an agenda. This talk, I think, is called Advanced User Interface Techniques and Principles. But really, it's just a bunch of little things that I slammed together to make a talk. So this is a list of things that I'm going to go through, and they're kind of independent, so maybe if you want to ask a question, ask it right away while we're dealing with that section rather than at the end. But at the end, after going through them all, I'm going to show an actual, I'm going to demonstrate it with like little things, little toy apps I've made. But I'm going to demonstrate at the end using an actual customer app to sort of see it maybe a little more polished and how it uses kind of all the principles. So the first thing I want to talk about is called, it's about subpanel layouts. So I want to talk about using subpanels that are a very foundational feature for making good UIs because you kind of modularize the front panel and put things inside other things. And so I see a lot, the most common use of subpanels I've seen is people have a running thing like a module which runs by itself. And they put its front panel in the subpanel of another module. So it's a hierarchical thing. But I want to show something slightly different, which I could call a layout. Wrong way. So a layout is something when often you have a program and you've got a bunch of graphs. So here I got 4 graphs showing data. But often this isn't a fixed thing. So maybe you want to have 6 graphs, or maybe you want to have 2 graphs or 1 graph or whatever. Or you want the user to be able to customize and select what they want and have the UI dynamically change the number of graphs or number of whatever it is you want to do. So it's not just graphs, but graphs is the most common. And this uses subpanels. So I want to show you how it works. So if I click on one of these graphs and open, when you have a subpanel, you can set it to allow you to open the block diagram of the thing in the subpanel. That's by default off, but I want to advise that you always put that on because it aids you in actually debugging your programs. So you see there's 2 open block diagrams because there's actually 2 subpanels. There's something in a subpanel which has a subpanel and there's something in it. So I'm going to open both of those.
Where is this feature to enable it?
If you have on a subpanel, there's if you right click, you can check mark allow user to open block diagram. So which one? Oh, that was that one again. So if I just move this so that I'm not looking at that one, you can see both these subpanels are extremely simple. All this is a graph. It's a graph that scales to the full pane. The graph itself is a control rather than an indicator, and it's a control connected to this. So you can write to this graph by calling this VI. It's got one output, and the output is just the reference to the graph. So basically, this is just a graph that you can use as a sub-VI and put into things, put in many places. And the other one, if you look at this one, all this is a set of 4 subpanels with splitter bars, so that it resizes nicely. And if you look at the code of this one, all it's got is the 4 subpanels have references, they go to an array, and they have an array of subpanels, and that's it. So all this is basically a very, that's why I call it a layout, because it's a layout of subpanels that you put in another subpanel, and you can swap out different layouts as your program wants to change its UI. And the way the code looks out in here is that, I can't even actually point at it. Over there is a bunch of pre-allocated clones of the graph VI. So the graph VI is pre-allocated clones. You just drop a number of clones. Here I've got 9 because I need at most 9 graphs. Make an array. And then the user, and then the user has selected what kind of layout they want. So this is 2 by 1. You call that particular layout. All you're doing is getting an array of subpanels, and then use those arrays with the graph arrays to basically insert them into the subpanel, and then call the different graph VIs and get the graphs, which you save as an array. Everything is done as arrays. And so that allows you, if you wanted, I've only done up to 2 by 3, but you could do 3 by 3 and 4 by 3 and so on. And have, or even have different things where maybe you have a big subpanel and a couple of little subpanels or something. You could think about doing a lot of different layouts. And you can do things like registering for events. You can register for events on all the graphs or on all the subpanels. So you can do things. So for example, I've added a little feature where, oops, it's not going to help much with 1 by 1. As you move over, I show the controls of the graph. So they're usually hidden. And when the mouse goes over it, I just show it. So that's to hide the features the user doesn't want. When you're doing a big UI like this, you want the user to not be bombarded with all the different little things. You want to hide them until they might want them. So hiding stuff until they mouse over something is a good way to do that. Okay. So that was subpanel layouts. Any questions on that?
What's the resource use? I saw you had the folder for updating. Is it a lot of...
Resource, sorry?
Yeah, how much resource is like...
For subpanels, nothing.
Is it efficient the way you do?
I don't think subpanels don't use any resources at all, really. I've never had problems with subpanels. I've had up to 4 or 5 subpanels deep and never had a problem with the subpanels itself.
Okay, just the nested nature of it, yeah.
So there's no real overhead. And one other thing I want to show now is a lazy UI update. So if you do extensive UI work, you don't see it with an example because examples are quite simple. But if you're doing something complicated with the UI, often it can take time, and it takes time in the UI thread, which is a kind of limited resource. So you can end up having actions that happen faster than you can update the UI. So you need to have a separation between your actions, which might, maybe you have 100 things happen a second. You can't update the UI 100 times. You have to have some way of updating the UI when you get around to it, rather than for every change. So I can demonstrate it here by, at the top there's some controls, the generation period, and here I have a simulated calculation time. That's the simulated work I have to do before displaying the graphs. So currently, my calculation time is 30 milliseconds versus 100 milliseconds, so no problem. If I put this up to, let's say, 1,000, now the data's coming in, I'm only updating once a second, but I'm updating with all the new events. I can make this even faster. So it's actually doing like 100 at a time. And the way that works is when I get a new data, so this is a new data, I've got a loop above which is just producing the data, and it's coming in by message. So I get the new data. This is all messenger library, by the way. This is a messenger library template. I get the data, I put it into 2 buffers, and then this is the point where you normally would think, oh, I've got to update the graphs because I've got new data. But you don't do that here. What you do is instead of actually saying replot, I record using a Boolean. You can see that in the replot Boolean. What I'm doing, I'm recording that I need to replot, but I'm not doing it now. And what I actually do is shown at the top. Let's see if I can plug in here. What I have at the top is a feedback of the timeout. And the timeout feedback is from a default unwired tunnel out. What that means is, for any event that happens, the timeout that's fed back is 0. And when the timeout that's fed back is 0, it means the timeout will execute as soon as the event queue is empty. So if I have like 100 new data readings to go, I will read all of them. They will set the Boolean to true. And when I get to nothing, then that will fire the timeout case. And in the timeout case is where I actually do the update. That's not it. Where's the timeout case? There. So the timeout case, I check, do I need to replot? Yes. Well, then I'll do my simulated calculation and I'll plot my data. And by doing that, I have separated, I kind of made it so that it updates as much as possible. So if there's very little calculation time, then it updates basically every point. But if something happens so that the calculation takes longer, or there's a burst of events or something, it'll handle all the events quickly and then do the update. And this makes that application a lot more robust, because often you start with a simple application and you do, okay, I've got a new data point, so I plot it. And then you start to add features to your display, which makes it take longer and longer. And then you add other stuff which might make the data come in faster. And then you get to a point where you start to have a queue that builds back because you can't handle events fast enough. And this is very robust at handling that. You can do it not just for display, you can do it for any kind of like calculation that doesn't happen all the time. So the key point is that you separate handling the data in the kind of business logic, what you need to do. Here I'm just recording it, and the actual display, which is handled when the queue is empty. So any questions about that?
Your mic.
Did I miss something, or am I?
Maybe I missed this, but can you not get into a situation where you're starving out and you're never updating? You're never updating your front panel?
Well, yes and no, but yes. But if you're in that situation, you're going to die anyway. Because if you can't handle your business logic faster than you're producing your events, then your program will fail. Right? But normally, the business logic, because it's not tied to the UI thread, it's not doing things like drawing big 2D pictures, it's not making property node calls, it's often much, much faster. And so the rate of handling this and these are like cyclic buffers is much, much faster than any kind of advanced UI technique. So, I mean, so yes, you can't say it's not starved, but I mean, all you're going to do is see it update before it dies.
So effectively, you have to put the redrawing of the UI to the lowest priority.
Yeah, effectively. Yeah. But the advantage of this is a very simple way to do it. And you can also, so here there's one Boolean. You can actually sometimes have a hierarchy. Like, say they change a parameter, which requires a big calculation. So that can be one Boolean. But then they change new data, which doesn't require the big calculation, just the display. And then maybe the user moves their cursor across the graph, which requires some kind of overlay to be drawn. And that can be an even lower priority. So you can have sort of a tier of I've had like 4 or 5 Booleans in advanced applications. Oh, I should show, in the actual plot data case, you have to set the Boolean back to false. If you don't do that, it runs around forever. So basically you're saying the Boolean just says, the UI is stale, update it at a lower priority of everything else. And then when it updates, it just says, okay, it's up to date. Okay. So another thing about, it's going to be a subpanel, is about tabs, in quotes, and selector controls. So this is sort of the standard way I do an application where I have a tab control. And so you have different tabs looking at different things. And then inside that, sometimes you want to have some actual ability to change the UI, some kind of selector control. And a selector control is like this, just the things to select, and the tabs. But no, these aren't real tabs. If I stop this and change the amount of hardware, which could be done dynamically, I got a different number of tabs. And the thing is, this isn't a real tab. What you see at the top is actually a radio button. And the selector control is also a radio button. They're heavily customized radio buttons that are basically just sitting there, and they're looking like tabs. So this is probably I bet people have used this quite a lot. A very standard way to do things. Inside the main thing is just one subpanel. And as you change the radio button, you change what you put in the subpanel. As I said, so this one is slightly different. It isn't a subpanel, it's just showing and hiding different controls. So it's a way of putting a lot of functionality into a program. How many people use this? I'd say this is probably the most standard thing I would use. Not everyone then. Do people use regular tab controls?
Well, you can use the tab control as an enum and then switch.
Yeah, another way to do it is actually when I use a tab control, I hide the actual tab bar, and I do it this way, because it's actually more flexible and kind of works better. And you can actually mix. Some things could be a subpanel, and other things could be a tab. You can actually mix and match different things in one way.
Does it expand and contract, like the size
Oh,
of it?
do you make calls? Sure, expand and contract, that's basic to me. It's not advanced.
Where do you do that scaling, positioning?
I don't do it, that's just basic lab view scaling.
Don't you ever have that if you make it too small, then it gets...
What I do there is I just make sure you can't make it too small. I mean, I have people who test this, they like test it for their customers. And the customers never make it too small, but the tester will go all over the place and make it too small. And you actually go and figure out how small you can make it without messing anything up.
With the resizing, the window, you can set a pane to resize the objects while you're resizing also, so as you expand and contract it, it'll change the size instead of,
But sometimes it
without an event, it'll do it
That,
automatically.
I find that one, the resize everything, it's hard to make that work well.
It works for like a graph or something, like where you have it right now, if you set the pane to resize as you're, I forget the name of the property.
Oh,
but-
resize as moving.
Yeah,
I don't know if I have that set.
you don't.
No, I don't.
Yeah. I was just saying that it's a thing you can do.
Have a pen resizing that you use. The pen size change.
You shouldn't do it while, yeah, otherwise it's like
Exactly, because while you resize, you get a bunch of pen size.
Yeah, that's true.
You can compare the old size with the new size, and if it's the same, then you know it's the final resize.
But you said
You get the events, yeah, but you can make it do nothing.
Yeah, well, in UI stuff, you can do a lot of complicated stuff where this moved, figure out where this is on the screen. And I try not to do that unless I need to, because you can really get bogged down trying to make it, oh, it doesn't quite work. And so I'm trying to do a bunch of simple things, right? So most of my panes are like, there's one graph and I just make it size to pane, and that's it. Or there's a set of buttons with a splitter bar. So I try to use the basic LabVIEW stuff because it's simple. So anyway, so let's go on to menu buttons. So I really like right-click menus. I like right-click menus because you can put a lot of functionality into an application without busying it up with buttons and things. So you can, you click on the menu, you have all sorts of actions. You can add an action to the menu very easily. One of the problems, though, is that users don't actually know the menus exist. We have a problem in LabVIEW where often we have, in fact, I've got it right there, a bunch of menus along the top that are all meaningless to the user. Like the user doesn't really care about most of the options. So one thing is actually to get rid of that menu, or at least make sure that it actually is just a limited number of options the user cares about. But the other thing I like to do is to use menu buttons. So a menu button, for example, is over here. That's the standard Google material design icon for a menu. And when you click on it, it opens the menu. Now, I'm not right-clicking on it, I'm just left-clicking on it. And also you can do something here where this is like a settings where you can find, I gotta set option 1. Yeah, option 1, blah, blah, blah. Or maybe I gotta set something here, and I can set things that way. And that's a quick way to add functionality. You want to be able to add things so that the user can change things without having a bunch of, okay, now I need a button and this and an enum, and I fill up this front panel with all these things. But as I said, the user often doesn't know the menus exist. Your UI needs to be discoverable. So they can see the button, and they can kind of figure out the menu and click on it. But for a graph, graphs often have lots of right-click options, like clear chart, that the user, again, won't find, because they don't know to right-click on things. And so what I like to do is to have it so there's a button on the graph, and when you click on it, you get the menu of the graph. So that's the actual menu of the graph, even though I clicked on a button. How do I do that?
trigger the graph menu in the bottom.
Yeah, how do I trigger the graph menu? I don't think, can you do that programmatically?
Change the mouse button. Change the mouse button from left click to right click.
That's part of it. Over here, I changed the mouse button from left click to right. So let me just show that part first. So here it is. Yes. So in the menu, for the settings, this is the mouse down question mark event, which is a filter event. And in that, I can change the button from 1, which is left click, to 2, which is right click. And so I just say a left click on this button is a right click, and that opens the menu. So that's the easy bit. Now for that other button on the graph, which is the chart menu button, it's the same thing. I turn the left click into a right click, and I also hide the button. So what happens when I hide the button? Exactly. Because this is a filter event. This is what's called. Actually, I've got a thing for it here. Hang on. This is lock panel defer processing of user actions. Now, when I first learned events, I didn't really understand how events work. And I think a lot of people have trouble with events. They're kind of like, what exactly is going on? They lock up your front panel, suddenly you get into trouble. So I want to describe how the event system works, because I want to explain what these lock front panel means, panel means. I'm using the mouse down ? Event, which always does this. So the way it works is Windows is firing a bunch of events, not our LabVIEW events, but actual Windows events. So it's saying, oh, the mouse is now here, the mouse is now here, the mouse is now here. Oh, the user clicked the mouse button down, or the user typed the key. That goes to, in LabVIEW, some kind of user action handler. I don't know what the proper name is. And what the handler does is it says, oh, the mouse button was clicked down. The mouse was last over here. What is there? Oh, this button is there. Therefore, I got to do a mouse down. Someone is registered for a mouse down filter event on that button, so I fire off that event. That goes through and says after firing off the mouse down ? It can fire mouse down, and then because the button is a thing it can change, it can do value change and actually change the value of the button. It's the thing that's actually changing when the user clicks on something. When you're locking the panel, what it's doing, it says fire off this event mouse down ? But then wait, just lock, stop. So this thing will lock and not stop, won't go to the next step until that event has unlocked it. So the actual event structure, while it's running, will handle that event. And when the event structure finishes, that's firing a signal, which unlocks the user action handler. And the purpose of this is it allows you to change the front panel partway through an event, partway through an actual Windows event. So what we do is we change the button from 1 to 2, that's one thing. But also hiding the front panel, hiding the button, means that it's no longer there. So when the next part in the action, do we fire mouse down, do we fire value change, do we open the shortcut menu, that falls through the button onto the thing beneath it, which is the graph. And so now in that causes the waveform chart shortcut menu activation to happen. And in that, I show the button again. So if you watch that, I go on it and I click on it, you don't even see it disappear. Because the actual UI can't refresh that fast. So I clicked on it, the button was hidden. I turned it from a left click to a right click. And then that opened the menu, which showed the button again. So that's a little trick. It's a nice trick because the principle is you need your user to be able to discover your functionality. And you don't want your function to be discoverable because it's a whole bunch of button actions on the front panel. You want it to be very natural and there. So having an actual thing that looks like a button for the actual graph, and it kind of is.
Where do you swap your mouse back? Where do you swap your button back?
You don't. So I did a left click. That came in. No, stop, go back, what's next? So in the process of handling this mouse left button down from Windows, it went through all the events it has to fire. When it got to mouse move ? It fired it off. In that process of handling that, I changed the button to 2, and then it carried on as if it was a 2. And at the end, it just threw it away, it doesn't matter. The button's finished.
It's a special feature of the filter event.
It's a feature of anything where you've set lock panel, which is on by default, which it shouldn't be, because that confuses people. But I want to point out that a lot of people just say, turn that off, turn it off, turn it off. It's there for a very good reason. It allows you to change the user interface mid-event. So you can do a lot of fancy stuff. Mostly I do this because I said I like simple things. But I've seen people do things like actually move a control in its place so that the mouse falls on that control instead. So you can really do some advanced stuff if you want. I don't necessarily recommend it. But simple things like hide the button, I think, is actually a lot of value for money. Because it's relatively easy to do, to just change the button. And it's really good for this, because I like to have menu buttons like that, because you can put a lot of features in. One other thing I want to show is this. So this button is not just a menu options, it actually has some states in it. So it knows what's checked. It's got some enums, which you can change. So I want to show that. That's another way of adding functionality easily. So that one, the settings. This is actually, you can get this. This is part of one of my toolkits, the Common Utilities Toolkit. it basically is, it's a VI that takes any cluster of basically Booleans and enums and generates a menu from it with tags that encode what to do. And then in the handling case, that's not it. Yeah, in the selection case, there's another VI which reads the tag, you give it the cluster, and it makes a change to the cluster. So with this, you can, if I wanted to add a new thing, if I wanted to add a new, well, you'll notice I don't even bother to type this because it's only defined in one place. If I start this again, now there's a GDevCon button, or a GDevCon setting that I can change. And that allows you to add functionality quickly, because you can just, okay, I need a setting for maybe make a log scale or something on this graph. So I can add very quickly a bunch of settings that the user can configure.
Have you ever found a way to add a submenu that starts with an underscore?
Does that not work? Oh, well, you're going to mess me up now. I never even tried that.
Actually, I think the first underscore is removed.
Let's see.
But if it starts with an underscore,
see if it works.
it just disappears.
Let's see if it works. Yeah.
Yeah, but yeah. Okay, maybe in a submenu, a sub item.
I don't know. This is custom code based on variants, so it's not, probably not the same as.
Yeah, no,
Anything
it's in the menu part of. Well.
So anyway, the advantage of this is you can really add. You can have quite a simple user interface. So I've got like charts and I've got like a couple of icons, but you can add a lot of functionality to it, and you can do it relatively simply. Because the menu, adding complicated menus is a pain, but this is a way of adding things relatively simply. So it makes it easy to say, oh, I want this option and this option, and you can throw it in like in 5 minutes. It's very quick. So any more questions on that? Not that one. Go back. Okay. Pin the corner trick. Hang on. Oh, so one thing you probably didn't notice is that when I'm running this, there's a button there. If I make it bigger, the button stays in its place. And you think, well, that's pretty boring. But actually, that's sometimes hard to do, because LabVIEW decides how you scale the graph, and it decides, oh, what you're going to do. It doesn't know you want it to stay in the corner. It decides by its own algorithm what to do. So I show it here. So here's an example. Here's a front panel, and I've got 4 icons over there. And if I make it full screen, the icons get spaced, and you can't quite see it, but they actually get moved further away from the corner. And that's not what I want. I want them all together, and I want them in the corner. So the way to, again, you could think of like positioning it, the pane change to like position it myself, but that's a lot of work. Oh, what, sorry? You could do a splitter bar, but sometimes, particularly on that previous button, that has to go over the graph. So there's no way to do a splitter bar. Also with splitter bars here, for example, I got the icons there, and I've got my list of plots there on the same level. So I can't do a splitter bar here. Splitter bars are good, but they're kind of limited because they're all rectangular. You can't put arbitrary splitters everywhere. Yeah, okay. So anyway, this is a trick that can be solved many ways, but the simple one is just to group. First of all, you group the buttons. Now, if I group the buttons and they get bigger, they all stay together because they're a group. They still get spaced in the wrong direction. So what do I do about that? You can't quite see it here, but sometimes if you have a little button on the big graph, the button can be moved over the graph or over the scale, and that's a problem. So what I do here is, you can't see it because it's invisible, but right in the top there is just a square that's invisible. So I just dropped the square, made it invisible, and I put it right in the corner. By grouping that, like that, when I space it, it's actually, I mean, I should have made it bigger, but that actually pins it in the corner because Lavi says, oh, the corner of this item is right in the corner, therefore I don't space it because, 0 times whatever is nothing. And that causes it to stay in the corner and not move, which is what you want.
I just still...
So that's the trick. But it actually saves you a lot of work because your other options is to say, oh, I've moved, the panel has moved, therefore I must find this thing and I must put it back to where it's supposed to be and do a lot of actual property node coding. But having little invisible things, which are your markers, and group them with things, allows you to do a lot of placing things. So they scale the way you want them to.
Yeah, I just wanted to have a comment on the underscore thing. If you make a menu item with an underscore, then it will disappear, and it will make it a separation in the menu click.
So who's talking? I can't quite.
I'm all the way on top.
Oh.
No.
So
that's a function in the menus. So when you put an underscore there, it will replace that in Windows with a separation bar. So you have menus which are separated in separate categories.
Are you talking about menus?
Yeah, in the menus, yeah. When you do an underscore there, that's what happens when you do an underscore in the normal menus.
Oh, is it? Okay.
Yeah, that's apparently a function of Windows, I think, that the underscore is replaced by a separation. And LabVIEW supports that, so that's what happens when you want to make an underscore in the item.
Okay.
Does this trick with the corner works in every corner or just in 0, corner?
I think it works in every corner.
Okay.
I think because LabVIEW, when it actually scales, it says, where is this thing? And it scales its positioning from the corner. And so if the positioning is 0, it's directly at the corner, then it won't move it.
Does then the ordering of the group depends? Is it like if you select first the corner and...
I don't think so. I think you just group them all. Because I think, as far as the positioning is concerned, it's just a box
yeah.
around everything.
I was going to say that I don't think it does work in every corner. I've seen that, but what you can do is when you right-click and you say scale with pane and it puts kind of the grid marks that are there, like the tic-tac-toe board, if you put the thing that you pin it to outside of on the corners outside there, it'll do the behavior that you're describing.
Okay. I actually never use scale object with pane. I just use...
Yeah. So
I put one graph and make it scale to pane, and then that's the behavior of everything else, because it moves everything else in the image. Okay, so now I want to talk about something which is more theoretical. So I'm going to wave my hands a lot. It's called the controller model view principle, which is my name for it. You might have heard of the model view controller, which is kind of a thing that's been developed. The principle is more important, I think. And I'm calling it controller model view principle partly so that you don't think model view controller, but also because that's kind of the important ordering, and I'll show you why. Hang on. So the controller model view principle is this. So you think of your software in the 3 things. So control is from the user exerts control, or something exerts control over, eventually, the model. The model is the model of the real world. So the model is the thing closest to the hardware, or the data files, or something in the real world, the thing. If you say the thing, that's the model. The model is either that thing, or it's the one step away from it, the representation of it in your program. And also in your program, you'll have various controllers and views. A view is something that displays or uses the data or the information. So the user might look at the front panel and see, let's say we'll talk about a furnace. Actually, I'll show it here because I've got. So here's the front panel. I'm going to ask you, what is the furnace set point? Anyone? How do you know it's 300? What if this furnace only goes to 200? I've typed in 300. Does that mean it's 300? What I'm trying to say is, even a thing as a single control is 2 things. It's a controller, I can type in what I want, and it's a view, it's telling me what is. So if I type in 300 on a furnace that's only set to 200, and it shows 300, that's a bug. That's wrong. It should only be 300 if it's actually set to 300. And if someone else types in 400 somewhere else, on some other part of the UI, that better is turned to 400 because it's a view. It's telling me what it is and it mustn't lie. So, so that's what this kind of thing, that the principle is. And if you think of model view controllers where they have formal frameworks, where they have an actual model part of the framework and they have a controller part of the framework and a view part of the framework. Here, regardless of what it is, every little bit of your code, like a setting or something, somewhere is the master copy, and that's the model. And any view of the code, anything the user looks at to see what it is, or anyone else reads, that's a view, and that must reflect what the model says. And then any kind of control change, exerted by the user or whatever, can't update the view directly. So if I type in 300, it can only stay at 300 if it actually goes to 300. So even though the controllers and views are tied together often in a UI component, they're actually separate. So the user exerts control into the model, and that model might go to the hardware or whatever. And then the views are updated by the model, and then the user sees the view. So that's the kind of the principle. I don't know how obvious that is. It might be very obvious or not obvious. But one of the reasons it's very important is it really simplifies coding because as long as you get the parts right, so this view updates from the model always, and the controller always gets to the model always, you can build up complicated code in a modular fashion. And it's actually, it's hard to show. It's actually quite simple. Let me show one thing here. So this is actually a demonstration project with Messenger Library. Most of this code is in Messenger Library. And it's the one that was actually developed over a series of YouTube videos that I did as pseudo documentation in Messenger Library. So this is a simple application. We have a top-level program. It launches an instrument actor. This is a simulated instrument. The instrument takes data. It has parameters, amplitude, frequency, period. And the information goes back up to the main application. So there's control and view in the main application as well. And the main can also have additional controllers. So here's an additional controller, which also has the same settings and allows you to change it. I can make a couple of those. Show. So the point is that if I change something, everything's got to change together. So if I change it down here, I change the frequency to 0.2, 0.3, 0.4, it's got to change everywhere. And that's because I'm following this principle of there's one place here that's the model of these settings. And everything is a view of it. And every place I exert control over it, I exert control by sending it to the model, changing the model updates all the views. So this is done by messages, but you don't have to do by messages. The principle is the same regardless of what kind of technology you're using. You have to think, does my code acting as a view always reflect the model of which there is only one place? So in this code, for example, the actual model of the setting for amplitude is just a cluster in a shift register, because that is the thing. And I can show you that. So if, for example, if I were to set the amplitude really, really high, like 500, which is outside the range that's allowed, you notice it goes to 3. It doesn't go to 3 because this control has a maximum range of 3. Because that's kind of violating the principle. The only person who decides what the maximum amplitude is the model. So in the model of instrument, whenever I get a new amplitude message telling me to change the amplitude, I apply the in-range and coerce, keeping it to 3. And then the code here. So here I apply the in-range and coerce, I record it, and then I update the view. So this is a local variable of the control in the front panel, that's a view. Local variables are often views. I'm notifying everyone else what the new amplitude is, so they can update their views. And the point is, this is the model. I know this is the model. This is where to put things like limits and things. And everyone else has to reflect what the model actually is.
Can I have a question on
Yeah.
that? So how do you handle the situation when someone changes the value on the UI? You are limiting it in your model and sending it back, but someone still holds the mouse on this control, for example. Does it jump, or you have some special handling for it?
You're reminding me of some of my users that managed to test my code in ways I never.
Well, I'm asking because this is something that we encountered, and I'm just wondering if my solution
I had
for
one
that-
user, I had one control where it does something, and I applied a little feedback trick. And it's good because one of my users tested it. Rather than type in, I want to change it to 600, he would click on it and he would do the mouse wheel. And he'd fire like 300 events, changing it up to 600. And that would be really disastrous if I hadn't done this trick, because you can fire like, I think, 20 events a second. Is that the rate at which things fire?
It depends on the refresh rate of your screen, I think.
Anyway, so it was
but
like 20.
I mean, even if the user keeps a constant value, then it still may jump between his value and your value, right?
Let's try it. It's not that one. It's one this one. So what do I do? Hold it
Well,
down?
you would need to have this amplitude control larger than 3 for that.
No, don't have a mouse wheel, but
In this actor on the right, for example.
I expect there could be a weakness. One of the problems with this is if it takes, say, a second for the model to update, then the user can temporarily think, oh, it worked, and walk away, and then it gets set back.
But you have the Boolean, you're just not using it at the moment.
Which Boolean, sorry?
The Boolean and the in-range and coerce, you can just catch it there.
What do I do with it there?
When you just don't send the value that comes out, you're always sending the coerced value.
Oh no, one of the problems here is that you must always send it back. So if it's 3 and I say set to 4 and it coerces to 3, I still send it back at 3 because that resets the control. Because the control just said go to 4, you just change it to 4. So it keeps it at 3 and sends it back, and it goes back to 3.
But what he means is if you set the control to coerce the values, then you won't be able, if you type in 4, then the control coerces it to 3. And I think it will send the 3 event.
Okay, that's fine, the 3 is allowed. My point is, the natural place to put this stuff is in the model, not in the controller. It's often nice to make the controls automatically update to the actual range. So particularly for these,
Excuse me, I have a question.
these sliders, for example.
So I have a question. Such a scenario, if model is not a simple storage for set value, but some hardware, and we are interested actually which value is set to hardware, not which is sent to hardware, there is some time log. And it's very typical with, for me, if I understand the concept correctly, I saw such solutions many times. So that user, for example, has value 3, set value 4. The value 4 is sent to the model, but during this log time, couple of hundred of milliseconds, model replies with value 3. After that, it replies with value 4. What user see? I said 3, 4. It is changed to 3. It is changed to 4 afterwards. So it's quite confusing for user. For what I found for such confusing, because we have 3 values. New value, set value is actually there is an actual value too. So actual value, okay, we show it in indicator, but between these values, if interface value shown in interface, new value, is not the same that is set value, it is just exposed in different font color.
Yeah, I've got to move on because I'm running out of time.
Okay.
Sorry. Okay, where am I going? Done that bit. Okay.
How much have you got left, Jenny?
I don't know, not much. I'm going to go over, sorry.
It's blinking, it's flashing, so.
We can skip the data display window and go to the customer app. How's that? Okay, so let me just stop this quickly. Go to the windows. So I want to show an actual application the customer has. So this is an application. It's actually for a spectrometer. And it's a spectrometer used in industrial processes for chemicals. And it's supposed to run for months at a time and just chug away getting data. But it can also be used as a more diagnostic as well. And so you can see some of the same features. So I have menu buttons. I can open project. Not that. Also, I have tabs, but the tabs are actually dynamic. So this is a project where it's meant for the laboratory where they're actually doing samples, putting samples and using the spectrometer directly. While this different type of project, which is used on the factory floor, catches things continuously. And it has more features in it and more panels. So you can dynamically add and remove panels. For example, I can, oops, get out of the way. If I want to turn some features off, something disappears. I want to turn it back on again, the Modbus appears. You also have things like, again, we have the different panels where you have different numbers of things, and it dynamically, if you want to display things, 4 things is 4 graphs, 6 things is 6 graphs, etc. So the menu buttons, this thing to do, is that everything? It actually does things, so it's got these little menu buttons again, so the user can discover the functionality. They are pinned in the corner so that they don't actually move around as they rescale. Things like this are also, some of the things are splitter bars. I didn't get to show the data windowing, but I'll talk it here. So this can run for months, so there can be a lot of data to display. If you have 1 million time readings, and you collect 1 million time readings and put it in a graph, it will be extremely slow. You just can't do that. So what this does is it only pulls up the information it needs. So here I'm looking at a lot. Actually, not a lot. I mean, this is quite a small demo. But I'm not displaying raw numbers. I'm displaying averages. This is using an SQLite file to store data. And rather than just get all the data and try to put it in a graph, it just says, well, I'm only looking at this range, and I only need, say, 3,000 points to do a graph. So I'll take averages and pull that data. And if the user changes the scale and reads in, it actually re-gets 3,000 points, only at a different time scale. And so if you get close enough, it looks at everything. It's also doing, see the overlay, so it's overlaying information. That's a 2D picture that gets redrawn every time you change anything.
The markers?
The markers, yeah. Another sort of application of the controller model view principle is if I open this display program, this is for looking at data. So I'm looking at the same data in my display. This is sort of for the user to look at data. It doesn't take data. But because you can see it looks identical, and that's because this program is both used used in 2 executables because it's a view. I can use it. So this is viewing the SQLite file, and I can use it in the main application, which is taking data, and in the application that is just looking at data. And they're tied together. So for example, if I put a new marker on, I'm going to look at the same spot. Where is it? It's this. Not the same spot. Anyway, if I put a marker on this graph, it will appear if I can find the same spot. Hang on, I'll do it. And I can do it from either one. So if I put a marker here, GDevCon. Oh, come on. Yep, there it was. Hang on, change the scale, which I can do because that, yeah, GDevCon 3. So these are 2 views, because they're both viewing the same data. In this case, the model is the SQLite file. It's actually good to make the model as low level, as close to the real thing as possible. Rather than, say, reading the whole file into memory and make that the model, if you have the right technology, and SQLite can do it, HDF5 can do it, I think TDMS can do it, where you can have multiple things, multiple connections to the same file. You can make the file itself the model, and that's one of the best ways to do it. So these two XEs are not communicating, they're just looking at the same file. So when I make a change in one, it appears in the other. I mean, with a slight delay because of polling. So yeah, so there's a lot of little tricks that kind of allow you to have a pretty good user interface. And I should probably end there.
Thanks,